equals negative g over 3. Negative 40 equals negative g, that's a 9. Let me use an x. And that's another trick I was going to tell you. If you've got one variable there, if you don't like the F or G or H or whatever letter they're using, put whatever letter you want to in there. It doesn't matter. Okay, who'd say? Hunter and, okay. Hunter, do the first step for me. What am I moving first? The negative 20. Move it over here. Randy, after I move it over there, what does it become? A plus 20. So, Hunter, what is it now? You change it to a plus 20. So, what do I have over there now? Good. Negative 20. Read for me, Randy, the rest of it. Negative 20. You got one more thing to throw in there. Equals negative x over 3. This is the type problem that I showed you right before we started. Do you remember that? I've got a negative in front of my fraction. What can I do with that negative? I can stick it down there next to the negative 3, or to the 3, right? Because negative x over 3 is the same thing as negative x over positive 3, same thing as x over negative 3. Either way you want to write it. So last step, what are we going to do there, Josh? Good. We got to move that divided by negative 3 over, so we change it to multiply. So we now have negative 3 times negative 20, which is a, so x is 60. Because x is now by itself, nothing else over there, you're finished. As soon as x is by itself, as soon as y is by itself, as soon as r is by itself, you are finished. Unless you want to go back and plug it in. Next problem. Nearly done, guys. Told you it was a short lesson. Because we're not doing example 3. Negative x over 4 plus 5.5. Negative x over 4 plus 5.5. Doesn't matter where I put that negative. No, it does not. Equals negative 3.2. Zach, what all do we have to get rid of? What all are we going to have to move in order to get x by itself? Close. Close. The negative 4. So really we're moving, instead of 4, we're moving a negative 4. Does that make sense? Because that negative we're going to put down there. So we got to move a 5.5 and we got to move the negative 4. Okay, that's kind of a trick question. So Brandon, what are we going to move first? The negative 4? Why? Okay, you can if you want to. That'll work. I'll accept that. Now what are we going to do? And what does it become? Perfect. Okay, you can go ahead and finish it. Excellent. So we're now left with, he says that's when it's negative, so be careful. Negative 8.7. So Brittany, read for me what I have now. Any questions? You okay with that? So Johnny, what's my last step here? Good. So we're going to multiply by negative 4 and it's gone. So x equals anybody, positive or negative? Positive. Negative times negative is a positive. Let's see, 32 and 2.8 would be 34.8. Any questions? No, they're pretty easy. Last problem. Leo bought 6 glasses and 6 mugs. We know that he was charged $3.99 for each mug, and that the total bill before taxes was $65.88. Write and solve an equation to determine how much Leo was charged for each glass. What's real close? 6 glasses, 6 mugs. Total. That's not how you spell total. So 6 glasses were, let's see, is that our x? We don't know how much the glasses cost. So 6 glasses, x dollars each. 6 mugs, it was $3.99 each. The total we paid, $65.88. Okay, let me explain. I told you before, writing an equation is a process. Okay, you're describing the process that you would use to find the cost here. What if, ask yourself this, what if you knew how much each glass cost and you knew how much each mug cost? How would you find the total price? Multiply 6 times the price of which one? 6 times the price of the glasses, and then also you'd multiply 6 times the price of the mugs, and what would you do with those two values? You would add them together, and what would it give you? The total, would it not? So again, you're telling me that you'll do 6 times the price of each glass, and you do 6 times the price of each mug. And what would you do with those values? You would add them together, and what would it equal? Well, it would equal the total, would it not? Does everybody understand that? An equation is a process. 6 times the price of each glass plus 6 times the price of each mug is going to equal to the total price. Plug in what you don't know and what you do know. Do we know the price of each glass? No, so that's going to be your x variable. 6x plus 6 times, do you know the price of each mug? $3.99 equals $65.88. Does everybody understand where that equation came from? Can we clean that up any? What do we know? You know how I do that? Would you use a calculator to multiply that? Wouldn't have to, because that's really close to $4, right? How far? Yeah, how far off of $4 will that be? 6 cents, because it's a penny less on each one, so it'd be 6 cents less. So do $4 times 6, and you get $24. But we know when we multiply that, it's not going to be 24. It's going to be 6 cents less than that, so $23.94. Everybody understand how we multiplied that in our head? Sometimes we don't have to use calculators. So look at the equation you've got now. Do you see you have a two-step equation? What am I trying to get by itself? Trying to get x by itself. So, Tessa, what are we going to move first? Well, what two things are we going to move to get x by itself? Tell me that. The 6, good. Yeah, $23.94. That makes sense to everybody? We have two steps. We move this and this first, and then we move this and this. Do you remember what the first step was? What do we move first? Why? No. No. That's that thing that I went over and over and over, and I said, y'all make sure you know this. Randy, what do we move first? Why? Why? But why are you moving that first is what I'm asking. You get rid of addition and subtraction first, and then you get rid of multiplication and division. That's about the only explanation I gave you for this lesson, was those two things. Addition and subtraction first. So it does become minus $23.94, and we moved it. It's gone. You can mark it out. We moved it over. So read for me, let's see, who have I not? Jesse, I hadn't got you yet. Read for me what I'm going to have left. Equals whatever you get when you subtract, right? Anybody got that subtracted? See, 8 minus 4 is 4. We got to borrow 1. 18 minus 9 is 9. It is $41.94. Last step. Grant, what are we going to do both sides now? Because multiplication, when you move it over, becomes division. So it's gone. You can erase it. X equals 41.94 divided by 6. We can use a calculator, or we can actually divide it. Let's see if we remember how to divide. 6 into 41.94. What do we do with our decimal? It comes straight up, actually. Go ahead and move that decimal straight up. Yes. Is it 42? No, you didn't borrow. See, you're going to have to make that an 18. So make that a 4. That's fine. So 6 into 4 won't go. 6 into 41 goes. 6 times gives you 36. Subtract. How much left over? 5. Bring down. 9. 6 and a 59? 9. 9 times 6 is 54. Subtract, you have how much left over? 5. Bring down the 4. 6 and a 54, 9. 9 times 6 is 54. No remainder, which there shouldn't be. Somebody explain to me why this should not come out to be to where you have a remainder. By looking at the problem. To get a price, yeah. Think about that. If we're trying to figure out what was the price of each glass, and if we get 6.99 or 6.998, something's wrong there. They overcharged you or something, because you should come out with a specific price. Does that make sense? Because they charged you $65.88. So obviously there was a specific, like $6.99, $6.98, $6.97, whatever, $5.99. There is a specific price for those glasses. If you came out with a remainder there, something's wrong. Unless there's tax. Well, even with taxes, is going to be a whole penny amount. It's not going to be even though it's 9%. When you add those taxes on, you're not going to add on .987. You're going to add on 98 cents. That makes sense. So therefore, you shouldn't, when you're dealing with this type problem, to where you're finding out the price that you paid for each, you shouldn't have a remainder.